we have learned several rules for the derivative. For example, if I have f plus g, then that derivative is going to be f prime plus g prime. So minus is the same thing, right? And if you have like a constant like a, then that prime will be just 0. And then k f of x, that derivative, that's a constant, then f of prime of x. So pretty much we learned a lot of things, a lot of rules. Now we're going to learn something new now. It's called the product rule. So you have f of x and g of x. If you have this product of two expressions or of the two functions, what is that derivative? Okay, so that is what we're going to learn today. I can prove something by the definition. That will be the limit, okay, delta x approach to 0, and the top part is going to be f of x plus delta x, g x plus delta x minus f of x, g of x, and over delta x. And I think also in the pre-calculus, I believe it's pre-calc 1, and if you have fg of x, this is called a product function, and that's the same as f of x times g of x, right? So that's a general idea. It's a product function. Okay, so leave that here. So we need to work on this. But the thing is, if you look at that, you say, wait a second, this is f of the new value x plus delta x, g delta x. Here is xx. There's nothing I can subtract or add. So I'm going to add a term minus a term. So I want you to pay attention to this, see what I'm doing. So I will have f of x plus delta x, g x plus delta x. Okay, if I add one term, see, if I minus, because I really like to minus this g of x, so I want this one, f of x plus delta x, g of x. Okay, so later if I combine these two terms, then I will have a g x plus delta minus g, right? So do you see that? I minus a term, then I add the term because that's the case. I'm not changing the value, okay? All right, now then I'm going to go ahead minus f of x, g of x. So this is the tricky part here, okay? And then divided by delta x. Now that is going to be limit delta x minus approach to 0. So for this one, like I said, I'm going to have f of x plus delta x. And then I have g of x plus delta x minus g of x over delta x. And then I'm going to go plus. So did you notice that for the later two terms, I can take a g of x out, and then I have f of x plus delta x, which is from here, and then minus f of x over delta x. Okay, so did you see this? That's really nice, isn't it? So this is one thing plus another thing. So I'm going to get limit delta x approach to 0. Then I have f of x plus delta x, and then g x plus delta x minus g of x over delta x. Okay, I go minus the limit when delta x approach to 0, gx multiplied by, I'm out of space here, f of x plus delta x minus f of x, isn't it? Okay, so did you find something really nice here? Okay, well, before you do that, did you find it? This term, this one, Is this just the g prime? Right? That's the derivative of gx. And this delta x, when delta x approaches 0, so f of x plus delta x, this is just fx. And this is g prime x. Okay? And then this minus will limit delta x approach to 0. So this is approaching to 0. This is exactly f prime, but this is just gx f prime x. Okay, so we got it. So what do we know? We know this. We can write it this way. You can write f g prime equals f prime g, sorry, plus. Did I say plus? Yeah, it should be plus. I'm so sorry because there's two negative parts and they're all distributed to there. So that would be f prime g plus f g prime. Okay, so everybody okay with this? How do we use this? This is important one, right? Fg, the multiplication Fg prime, which is f prime g plus Fg prime, f prime g. So that was, you can also write d dx, okay, f of x times g of x. So that's the derivative of that, which is f of x d dx g of x, okay, plus g of x. Well, there's so many different ways to write that, but whatever you like, f of x. Or you write you write f of x g prime x plus gx f prime x. So they're all different ways to write it, okay? So hold on one sec, I need to turn off something. Okay. All right, so let's see how do we use that. I want to give you one example here. Uh, let's say this is h of x. That's a function, okay? And this function is this, is 2 plus 5x multiplied by 5x minus 10x squared. It looks like this is exactly the h of x is the product of two functions. So that was f of x is this guy, and the g of x is this guy. So h prime x will be this 2 plus 5x prime times 5x minus 10x squared plus, I just copy the first one, and then I take the derivative of the second one. Okay, and what is the derivative of this? This is the sum, right? Sum of two terms, but this one is a constant, so the take prime is 0. So this one is 5. So I get a 5 times 5x minus 10x squared plus, now I copy this 2 plus 5x. What is the derivative of this term? That is 5 minus 20x. You get that? Okay. So this derivative, you get 5. This derivative, this 2 go to front to become 20, and here the power becomes 1. Now, once you have this, you only need to simplify that. The rest is fairly simple. It's 25x, okay, minus 50x squared. That's the first two terms. And then later, you're going to use the distributive property, so it's going to be plus 10 for your first times the first, outer times the outer, which is negative 40x. Inner times inner, you got a 25x. And then last, so you get a minus 5 and 20, that's 100x squared. Now, when we combine like terms, we find the square term here is a negative 50, here is 100. So I got a negative 150 x squared. And what about the x terms? You have 25, that's a 50 minus 40, so you get a 10x. And then you have a number, which is 10 at the end. Okay, so we use the product rule. We got this derivative of this h. What about if you think, oh, can I just use the distributive property to expand this expression and then take derivative from there? Of course, I want to show you that you should get exactly the same answer. Okay, so let me just use the FOIL method to expand this h of x. So that equals, okay, so that's a 10x of FOIL, right? First by first, outer by outer is going to be minus 20x squared, okay? Inner, so that would be plus 25x squared, and then 5 times negative 10, I got a negative 50, x to the third. That's your h of x. You expand that. Now you take the derivative of it, you're going to get a 10, okay, minus, here it's a, you might want to combine these two terms first. Let me just go ahead and write it. So let me write the higher degree first. Sorry. So that would be negative 50x to the third. And then this becomes a plus 5x squared, and then plus 10x. Okay? Now I take the derivative of that. So 3 goes to front. I get a negative 50 times 3. So I have a negative 150x, drop 1 degree. Okay? And then this 2 go to front, multiply by 5, I get a plus 10x. Okay? And then here I get a plus 10. So if you compare with what we just did earlier using another method, use the product rule, we get exactly the same answer. Okay, so let me just write h of x equals this. So you get exactly the same answer. So I use this question to show how do you prove the product rule, and how do you work on that. And of course, if you next time when you see like a polynomial or expression multiplied or function multiplied by another function, and of course you can just either use the method like this to distribute that. If it's polynomial, you can do that and then go ahead and find the derivative, or you can use the product rule. But sometimes you cannot just distribute things to get the answer. For example, if I give you y equals 5x squared sine x. Okay. Now, if this is the case, you cannot distribute. Okay, forget about that. We're going to work on this. Now, how do you find a prime? So that would be one function is a 5x squared. Another function is a sine x. Isn't it? So that's one function times another function. Therefore, y prime will be, you can either take the derivative of the first times the second, or you can copy first to take a derivative of the second. Either way, because there's two terms. So let me just write it again. Fg prime, which is f prime g, plus fg prime. Of course, you can just change the order. So let me just copy the first one, 5x squared, multiply by the derivative of the second term, and I'm going to multiply, plus the derivative of the first term, and then I'm going to copy the second term. So that was fg prime plus f prime g. Okay, so 5x squared. What is the sine x prime? That is cosine x. Okay, and then what about here? What about a 5x prime? 5x prime is going to be 10x. Okay, and then sine x. Okay. And it's interesting because sometimes they ask you to pull out all the common factors. I don't know why they want to do that, but if you like, you can definitely put out 5x, and inside you have x cosine x plus sine x. But for me, it doesn't matter. If you give me this, I treat that right. If you give me this, I also treat that as correct answer. That is okay with me. Okay, so you want to try one more? Okay, I'm gonna y prime. equals 5x cosine x minus 5 sine x. You probably see that I like 5 a lot, right? Okay, so this is y. This is given y, and I'm looking for y prime. So y prime equals, again, see, this is the product, right? 5x times cosine x. That's the product of two functions. And here is just another function. This one is very easy to take the derivative. So y prime will be 5x times cosine x prime plus 5x prime cosine x. Okay, and then minus 5 sine x prime. Okay, now go ahead. So that will be 5x stays, but cosine prime is a negative sine x. Okay, and this 5x, if you take the derivative, you get a 5. So you get a 5 cosine x. Okay, and this one, the 5 stays, but the sine derivative is cosine, so you get a 5, negative 5 cosine x. So the good thing is you find there are two terms you get canceled out. So you have a negative 5x sine x. It's like playing a magic, but okay, when you see some question look like this, it looks a little complicated, but don't be scared. You just follow the rules we learned step by step. You should be able to get the answer. Okay, that's it for the product rule.